Okay, we're here to continue with another section. This will be a section about an application of integration in economics. We'll be talking about what are called consumer and producer surplus. This is homework 13, I believe. Yeah, homework 13 on my math lab. This will be the only section from chapter 5 that we talk about. Okay, so first let's briefly review a little bit of economics topics that we've already seen a little bit of. So in economics, we frequently are talking about supply and demand curves. And before we graph those, let's talk about what the coordinate axes represent in these contexts. The x-axis is the quantity of, if you have a company or an industry, the x represents the number of units that are being produced. So the units here, we're just going to call them units. That's whatever the product is in the industry. So it's how many cars you're manufacturing, or how many television sets you're selling. All right, so whatever the units are. Then the vertical axis, or the y-axis, we'll call it the p-axis. That's the price. And it's the price of a single unit. So how much you're selling a car for in this industry, or how much a television costs to buy in the market. So the units here, we'll just call them dollars. Well, not quite. So what price represents is how much a single unit costs. So the price is not just dollars, it's dollars per unit. And I'm being simple here. In general, you may be measuring in millions of units or thousands of units. Your price may be thousands of dollars per unit, or thousands of dollars per thousands of dollars per 10 units, whatever. These are the simple cases. In simple case, our x value is just how many of that product are you selling, or how many of that product are you producing. The vertical axis is the price of a single unit. So if we think about an area, I don't want to graph anything just yet, but if we had like a rectangle in this coordinate system, what would that area represent? Well, think about the units. It's dollars per unit times units. And as we talked about, per means division. So dollars divided by units times units. The units cancel and just give me dollars. So an area in this coordinate system represents a dollar amount. Okay, so that's basic point I wanted to emphasize before we talk about these concepts. So let me keep the coordinate axes, and I'll keep I'm going to need the space, so let's erase these unit stuff. Okay, so let's talk about the demand curve first. So a demand curve is going to be equation P is equal to some function of x. So P is equal to d of x. This is our demand curve. And what it represents is if you tell me an x, so you tell me how many of a product you want to sell. So x is how much you want to sell. P, the output, would be the price you would have to set to make it palatable to enough consumers to buy that many products. So you decide on how many you want to sell. The output of this function tells you what does the price have to be to allow you to sell that amount. So there will be consumers who demand that amount of the product. So you can logically think of it. If I want to sell more, if X is bigger, the price has to come down. You have to set the price lower if you want to sell more. So a demand curve is typically going to be a decreasing function, something like this. And we don't know exactly what the shape's going to be because it's going to depend on different assumptions. But it's some decreasing function like this. So that's P is equal to D of X. And let's, for now, I'm going to get into supply curve in a second, but for now, let's just say that we actually set the price at some P here. Let's call it P sub E. That's going to be equilibrium eventually. But say we set the price at P sub E, that means the point on the curve will tell us an X value, a corresponding X value called X sub E. And if I set the price there, then this is how many units get sold according to the demand curve. It's more complicated once we bring supply into it. But once we have an X value and a P value, then we're selling this many units of the product. We're selling them at this price. So this rectangle here, the area of it, again, like we said, the area is a dollar amount. That would be our revenue. The area would be the revenue. Price times quantity sold would give me revenue. All right, but here's the new concept. There's this area up here that also means something. So what does that mean? Well, if we had set the price higher, so if the price was up here, there would still be people willing to buy at that price. There would still be people willing to buy the product at that higher price. And so what this area up here represents, let me use a different color here. Red looks different enough. That area up there, that's the amount of money that consumers would have been willing to pay beyond what they're actually paying for the current amount. Okay, so everybody in the market is buying at this price. This is how many are being bought, but there are people out there who would have bought their units at higher prices. So this area up here is that extra money that would have been spent if everybody buying had paid the absolute the largest amount that they were willing to pay. They didn't have to pay that amount because the actual price is here, but there are people who would have paid more. So this up here, this area is the consumer surplus. Okay, let me write the formula for it. So consumer surplus, we'll call it CS. Well, it's this area up here, and what we do to calculate that is we take the area underneath the demand curve, so this total area underneath the curve here, and then subtract the revenue. So it's the extra area beyond this rectangle. So that's going to be the integral of my demand function, d of x dx, from 0 to whatever my x value is, my equilibrium x value, which we'll worry about in a little bit. So I integrate from 0 to the equilibrium x value, and then I subtract. That integral would give me the entire area underneath the curve here. if I just want the surplus, I then have to subtract this rectangular area, which is just the product, XE times PE. Okay, so that's consumer surplus. Let's talk about producer surplus next, and then we'll do a couple examples where we calculate both of them, because they're both very similar to each other. All right, so let's erase some of this stuff. I don't want the curve. Okay, so now we have a supply curve. P is equal to S of X. This is the supply. And it's a function that tells me, now looking at it from the business's side of things, if we want the business to produce X units, the price has to be high enough to justify that production. So if we decide on a number of units that we want to be produced, this function tells me what does the price have to be to persuade the company to produce that many units. Okay, so the more units I want to sell, that I want to produce, that's going to require a higher price to justify it. So this is going to be an increasing function. Let's see. It may not start down here at 0. Let's just assume it does, but it's going to be an increasing function like this. And so again, suppose we have an X value and a corresponding price in mind, then that's that same rectangle as before. The area of that rectangle is the revenue. Make sure I say this right. Right. So the total region here would be the revenue. Now, analogously to what we saw with the consumer surplus, if I had set the price lower, the companies would have been willing to produce some number of units. Okay, it's just to produce XE, this total number of units, I have to set the price all the way up here. But if I had lowered the price, there would have still been some production. So the area under here, under this curve, that's the amount of money that the company actually requires, that actually wants in order to produce this amount. This is the total amount of money it would need to take in to justify producing this many units. But it's actually receiving the revenue. So it's actually receiving this extra stuff up here, this extra part of the rectangle above the supply curve. So this region here, that's the producer surplus. So it's the part of the revenue beyond what the company actually needs to produce that amount total. So the producer surplus is going to be this rectangular area minus the area underneath the curve. So that's XE PE, or whatever I said before. XE times PE. That's the rectangle area minus the integral of this curve. So that's the integral of the supply function, dx, from 0 to XE. Okay. So those are our two definitions of these two types of surpluses. Next thing we need to talk about is what is this XE and PE? How do we figure those out in general? So we'll come back and use these formulas, but let's talk next about supply and demand at the same time. Okay, so we have a supply function drawn, more or less. If we have a demand function, that's going to be some decreasing function like this. That's P equals D of X. And so one of the first things you learn in whichever economics course this would be is the way that price is determined is by finding the intersection point of the two curves, the supply and demand. When supply equals demand, that's what the price is going to settle on. So this intersection point here, that's the equilibrium point. So let's label that, I guess. That's the equilibrium. And so the reasoning behind, I don't want to get bogged down too much in this, but the reasoning behind that is if I set the price lower, so if I set the price lower, the supply would be here. They'd be willing to supply this many units. But meanwhile, the demand curve would be over here at that price, and they'd be wanting to buy more. So there's demand that's not being fulfilled. So there'd be room to raise the price and still be able to find people to buy the extra units. Likewise, if the price was higher than that, there'd be more supply than there was demand. So the companies would be making a bunch of extra products and nobody would be willing to buy it. So they'd be losing money by making extra stuff, making stuff that doesn't get sold. So the two forces meet in the middle, and that's why it's called an equilibrium point. The companies are producing exactly the amount of product that there are people willing to buy. So people are willing to buy exactly the amount of product that's being made. Okay, so the equilibrium point we find by setting the two curves equal to each other and then solving for x. And that gives us the x value. Then we plug it into either function to find the p value. Okay, so now let's do an example of, so by the way, just one more point before I erase this picture. So in this picture, the consumer surplus, that was this region up here. The producer surplus is this area here. So overall, there's these two surpluses. That's like the net. That's the overall benefit that everybody's receiving. The consumers are getting extra beyond what they're willing to pay. The producers are getting extra beyond what they're willing to sell for. So together, these two areas give us kind of the total economic benefit of this this industry. This is the mean cat who won't leave me alone. Tap it. All right, so let's do an example with actual functions now. Okay, function. Let's say I want to find, well, let me give you the functions first. You gonna leave? All right, the function, I need some supply and demand functions. So d of x equals x minus 5 squared and the supply function is x squared plus x plus 3. Okay, so first part of the question, find the equilibrium quantity and price, let's say it like that. So equilibrium quantity, that's what I was calling x sub e. Equilibrium price is what I was calling p sub e. Okay, so we need both of these to find the consumer and producer surplus. Yeah. So all this is an algebra question. I take my two functions and I set them equal to each other. So x minus 5 squared equals x squared plus x plus 3. And the way I want to integrate, or the way I want to solve that is probably going to be, let's multiply out this parenthesis here. X minus 5 squared is going to be x squared minus 5 times x times 2, so minus 10x. And then minus 5 squared is plus 25 equals x squared plus x plus 3. Both sides have x squared, so if I subtract x squared, it's going to disappear from both sides. So I have negative 10x plus 25 equals x plus 3. Let's add 10x and subtract 3. That'll give me 22 equals 11x. So x equals 2. So x sub e is 2. That's my equilibrium quantity. Okay, so let me erase this work. We found equilibrium quantity. The equilibrium price is whatever we get by plugging this x value into either of these two functions, the supply or the demand. They should give me the same value if the work I just erased was correct. If I didn't make any mistakes in my work, if I plug this x value into D, I'll get the same answer as if I plug it into S. So let me just plug it into D. D of 2 is going to be 2 minus 5 squared. That's negative 3 squared. That's positive 9. So P sub E is 9. Let me write that over here. Okay, and by the way, so our equilibrium quantity and price, they should always be positive numbers. It won't make sense to have a negative quantity, and it won't make sense to have a negative price for any real world economics situation. Okay, so we have our equilibrium figured out. Let me erase. I need to keep the numbers, so I'll leave those over there. But now the question is, we'll do one at a time here. Find the consumer surplus. So CS for consumer surplus. So you have to remember which is which. Consumer stuff relates to demand. Consumers demand, producers supply. So the consumers demand, so we're dealing with the demand function. So demand function was the decreasing one, and so for that we need to integrate the function and then subtract this rectangle. So this is going to be, and you can have the formula in front of you, but the consumer surplus is going to be the integral of my demand function from 0 to my equilibrium x value, which was 2, and then I'll subtract my revenue, which is just equilibrium units times equilibrium price. So 2 times 9. Let me replace d of x with its actual function. Okay, so I want to integrate x minus 5 squared. There are two ways I could reasonably do this. One way would be multiplying it out. So multiply out the parentheses, x squared minus 10x plus 25. Then I get a polynomial. I can integrate that. Another way I could compute this is with substitution. The substitution method from a couple sections ago. This is just a power function, but with a different function inside of it. So I could make the substitution u equals x minus 5. Then du would be 1 dx. So my integral would become the integral of u squared du. And now I'd have to change my x values. If x is 0, u would be minus 5. If x was 2, u would be negative 3. Yeah, that's fine. Yeah, it just seems strange because it's negative. I'm going to have minus 18 here. I'm going to need more space to compute this. But there's nothing wrong with doing it this way, using substitution. There's also nothing wrong if you want to multiply this out and just integrate it with no substitution. Let me copy this. Okay, so now it's just a simple power rule here. That's 1/3 u cubed. I need to plug in -3 and -5 minus 18. So 1/3 -3 cubed minus 1/3 -5 cubed minus 18. -3 cubed, that is -27. So that's -27 over 3. 5 cubed is 125, so it'll be minus -125 over 3 minus 18. So that's going to be minus makes plus. 125 minus 27 is 98. Yeah, 98 over 3 minus 18. And what is that? 18 is 30 plus 24, 54 over 3. So that's 44 over 3. Okay, so our answer to the consumer surplus is 44 over 3. Let me erase and just say one more thing about it before we go on. So my consumer surplus answer is 44 over 3. To make that a little bit more digestible in real terms, as a decimal, that's approximately 14.67. These would be dollars, and just dollars. That would be the if our functions are giving us outputs in dollars, then this would be dollars. If it's like $1,000 or whatever, this would be $14,000 and $670. Anyway, but it's a dollar amount. It's a real monetary total. It's not dollars per unit or anything like that. It is the amount of money that the consumers are saving by buying at this price, buying two units at this price. Because there are consumers who would have paid more, but they don't have to pay as much as they're willing to. They were able to pay a little bit less. So they are saving money beyond, that they would have been spending otherwise. Okay, so consumer surplus is this. Now let's do the producer surplus. So this will be part C. Again, you can have the formulas in front of you as you do these problems, but just to remind you which one it is. So producers supply, so they use the supply curve. Supply curve is increasing, so it's going to live inside of our revenue rectangle. So the producer surplus is the area above that curve, but inside this box. So we're going to do producer surplus equals the rectangular area, that's 2 times 9, which is 18 again, minus the area under the curve, which is the integral of our supply function. So integral of s of x dx. But in our case, it's x squared plus x plus 3. And we're integrating from 0 to 2 again. It's always the same x interval for both of our surpluses. Okay, so now we just have to do this and be careful with our signs. So 18 minus, let's put the parentheses here. Antiderivative of this would be 1/3 x cubed plus 1/2 x squared plus 3x. And I'm going to plug in 0 and 2. Now, luckily, if I plug in 0, this whole thing is 0, so I don't really have to plug in 0. So I just really need to plug in 2. We have 18 minus 1/3 times 2 cubed plus 1/2 2 squared plus 3 times 2. But that's all being subtracted. So make sure there's parentheses around this whole thing here. So 18 minus, this is 8/3 plus 4 divided by 2 is 2 plus 6. So that's 8/3 plus 8. I guess we can make this a little bit easier. 18 minus 8 is 10. So this is 10 minus 8/3. 10 is 30/3. So this will be 22/3. So our answer for producer surplus is 22/3, but the interpretation is that is approximately 7 1/3, so 7.33. So that means producers are earning an extra $7.33 total beyond what they would be willing to earn to sell this amount of units. Right? So let's do another quick example. Okay, I guess this works. D of x, the demand function, is 100 divided by square root x. S of x is just square root x. Okay, same questions. We want to find these two surpluses. No matter how it's asked, though, if that's our ultimate goal, we still have to kind of do it in a step-by-step process. Our first thing we have to do is find the equilibrium. So for that, we're going to set our two functions equal to each other. In this case, I want to multiply both sides by square root x to get rid of this denominator. Well, if I multiply square root x by square root x, that's just x. So that's square root of x squared, which cancels and gives me x. So my equilibrium quantity, x sub e, is 100. My equilibrium price would be what I would get if I plug this x value into either of my functions. So let's use s since it's slightly easier. S of 100 would be square root of 100, which is 10. So the equilibrium price is 10. And now we're ready to do our surpluses. So consumer surplus, that's our integral of the demand function. I'll come back and put the bounds. But the integral of the demand function minus our revenue. The revenue is xe times pe, so 100 times 10, that's 1,000. Now let me just mention something about these bounds. Let me just go with what the formula tells us to do. We're always integrating from 0 to the equilibrium quantity, the equilibrium x value, which is 100. Now technically, what I've written here is what's called an improper integral. This function's not defined when x is 0. Okay, if I plug in x equals 0 to this function, that's undefined because there's division by 0. Now it's going to be okay. I'm just going to brush the issues under the rug here. It's going to be okay once we take the antiderivative of this. I'll get a function that I can plug 0 into. So we'll be okay. But that's just, this specific function ends up working out if I treat it like, if I just ignore that issue. But I don't want to worry about it, just in case you noticed that that is an issue here. But if we want to integrate this, this is the same thing as 100x the negative 1/2. So the 1/2 power is the square root. The negative exponent comes from the fact that it's in the denominator, remember? So if we integrate this, we have to increase the exponent by 1. That gives me positive 1/2. Then I have to divide by 1/2, which is the same thing as multiplying by 2. So I'm going to end up with 200x the 1/2. Plug in 100 and plug in 0. 1/2 power is the same as a square root. So when I plug in 100, square root of 100 is 10. So this will be 200 times 10 is 2,000. If I plug in 0, that's 0. So minus 0 and minus the 1,000 that's already here, that gives me $1,000 as my consumer surplus. All right. And finally, producer surplus. That formula is the opposite subtraction. We take the revenue, which is 1,000, and we subtract the integral of our supply function. So square root x dx, and it's the integral from 0 to our equilibrium units, equilibrium quantity. All right, so this is our calculation. To save space, let's go ahead and convert square root x to x to the 1/2. That's going to be x to the 3/2 when I add 1 times the reciprocal of this, so 2/3. Then we're plugging in 100 and subtracting 0. So we have 1,000 minus 2/3 clear with this. We're plugging these numbers into this function, and the subtraction that occurs is all inside this minus sign. So this minus sign will apply to everything. In this specific function, when I plug in 0, that just disappears. So this is just going to be 0 here. Okay, so this is, again, brief review about how fractional exponents work. I'm raising 100 to the 3/2 power. The denominator power, that's a root. So that tells me I'm going to take the square root of 100. That's 10. I still have that numerator power to deal with. So I still have a 10 cubes to calculate. 10 cubed is 1,000. So 100 to the 3/2 power, that's 1,000. So take the square root, get a number, then raise it to the third power. That gives me 1,000. So 2/3 times 1,000. So I have 1,000 minus 2/3 of 1,000. That gives me 1,000 divided by 3, or 1/3 of 1,000. And that's going to be what, $333.33? Oops, 333.33. So that's our producer surplus. Okay, so that's just one application of integration, illustrating the kind of ways it's used in different areas. So it's real in general. If you want to generalize this idea, integration is about finding areas. We've talked about that. It's about finding areas. So if you can interpret what does an area represent in a given context with a given kind of function on these axes with their given units, then integration can help you calculate whatever that quantity is that those areas represent. So in this case, it represents dollars or money, and we can figure out revenues and surpluses and all that. But there are similar ideas in any other quantitative arena. All right, so that's it for section 5.1. So like I said, that's homework 13 on MyMathLab. My goal, the next section, we're going to talk about a few sections in chapter 6. So 6.1 is absolutely necessary. It's just a basic introduction of what chapter 6 is about. 6.2 we will definitely cover. I intend to get through 6.3. 6.5 is the other topic that is kind of aspirational, that ideally we would cover. Under normal circumstances, I've never been able to talk very much about 6.5. In these circumstances, I don't really want to try it because it's a harder section anyway. But we're not really missing out because, like I said, ordinarily, best case scenario in the past, I've been able to briefly mention the topics but not really dwell on them very much. So we will finish 6.1, 2, and 3. So that's homework 14 in its entirety we'll cover. Homework 15, the last homework, there are a few problems on there that come from 6.5. You can ignore those. I'll tell you what they are when I cover 6.3. All right, so I'll stop there.